Hello, everybody. Hope you guys are doing well. You guys are continuing to stay safe, I hope. You'll have to forgive me a little bit. As I'm recording this video, it's like 11:15 p.m. on Thursday night, so I am a little sleepy. Normally I try and wait to record these videos after my wife and baby go to bed. And my wife and I were up playing a board game until like 10 or 10:30, so had to record the Math 8 video first, and now this is a little bit later, so I'm a little tired, but we're going to go ahead and go through this as best we can. Hopefully you guys are doing well. I'm excited. This is the last lesson of the chapter. Yay, so we get to wrap up chapter 10 today, which means next week we will take a test over chapter 10, which is exciting. And then we'll take that just before spring break. So next week you guys have Monday and Wednesday of class, and then Thursday and Friday will be the start of spring break, and then all the week after that will be spring break. So exciting stuff. Hopefully you guys are planning on making the most of your spring break. I know it's kind of like we're on an early spring break right now almost, but hopefully you guys can do something fun for spring break other than just being cooped up inside and probably going crazy. So let's go ahead and get started. Oops, don't want that up yet. All right, so our objective for today is to find and use trigonometric ratios. Now, before we get started with that, I kind of have a little bit of a story for you guys. Okay, so this is a story of two Indian people who fell in love. Okay, these two Indian people are Chief Three Feather. Chief Three Feather is, Chief Three Feather is right here, handsome fella. I know you guys love my artistic ability on the mouse. So Chief Three Feather, his name was Three Feather because he always wore three feathers. Okay, and then his wife was named Idanoa just because she wasn't very smart, and anytime she was asked a question or she had to answer something, she would always say, "I don't know." So they called her Idanoa. Okay, well, Three Feather and Idanoa fell in love, and they ended up having a child together. Okay, this lovely baby right here. Look at how handsome he is. Okay, well, they're trying to figure out a name for this child, and Three Feathers asked his wife, "What do you think we should call him?" And she said, "I don't know." She didn't have an answer for him. She wasn't very smart. She didn't have many ideas. So the two of them just simply couldn't come up with a name. So in the meantime, until they could come up with a name, they just called him No Name. So right now he's just No Name. Well, as No Name grew older, he developed a friendship with a young man. This young man was born with a birth defect. He was born without one of his eyes. His name was, as you can probably guess, his name was Old One Eye. Okay, Old One Eye. One day, old No Name, his dad kind of grew sick. Normally old Chief Three Feather is the hunter for their tribe. He'll go out and hunt, but unfortunately he fell really sick and he wasn't able to go out hunting. Okay, so No Name volunteered to go out hunting with his old pal One Eye. Okay, well, as you can imagine, having only one eye kind of means that you're not very accurate with the old bow and arrow. Okay, so as they're out hunting, One Eye, he finds a buffalo. He eyes it up. He stretches out his bow. He fires, and unfortunately, the arrow went right through old No Name's big toe. Yeah, right through. You can see, went right through. It's all bloody and everything. The toe is bleeding and everything. Well, as he gets this arrow in his toe, he gets news from the tribe that his father is doing really bad. So he really needs to stop the bleeding. So he gets this bowl of water from the river, He fills up this bowl with water from the river, and he just soaks his toe in this big old bowl of water to stop the bleeding. And once he gets home to his parents, okay, his father's on his deathbed. He says, wow, No Name, you're going to be chief one day, and I can't have you be chief without a name. Okay, and he sees his son with his big toe in this bowl of water, and he says, I know just the name. I know just the name for you. And he names him SOHCAHTOA, because he was soaking his toe in this bowl of water. So, from that point on, No Name was then known as SOHCAHTOA. And once his father ended up passing away, he became Chief SOHCAHTOA. So, that is the story of how SOHCAHTOA became chief and earned his name. The end. Okay? Alright, so let's go ahead and get started with our lesson for today. Ratios of the side lengths of a right triangle are called trigonometric ratios. So these only work with right triangles. Okay? And these are called trigonometric ratios. Again, I would go ahead and make sure you have your notebook out, and I would write down each of these ratios in your notebook. Remember, you can use these on your quizzes, on your tests, so make sure you're taking good notes. So we've got 3 definitions of trigonometric ratios. There's sine, cosine, and tangent. Okay? These only work for right triangles, by the way. Okay, so we've got our right triangle right here, and we've got angle A right here. That's this angle right here is angle A. So the sine of A, you can write it as S-I-N-A. It looks like sin A, but it's actually pronounced sine of A. Okay, to find the sine of A, you take the length of the leg opposite of angle A. So here's angle A. The length of the leg opposite is this leg right here. And then you divide it by the length of the hypotenuse, which is right here. So you do opposite, the leg opposite, over the hypotenuse. To find the cosine of A, you write cosine as C-O-S, and then that's the cosine of A. To find the cosine, you take the length of leg adjacent to A, which is this leg right here, over the length of the hypotenuse. So the adjacent over the hypotenuse. Okay, and then to find the tangent of angle A, that's written as tan A. You take the length of the leg opposite of angle A, that's this leg, over the length of the leg adjacent. So it's opposite over adjacent. Okay. Now, it'd be a good idea to have these rules memorized. Now you might think, gosh, how in the world am I going to memorize all of these 3 definitions? They seem somewhat complicated, right? Man, if only there was some sort of an easy way that we could understand and remember these, right? So like think of sine of A as opposite over adjacent. So like sine, we can do sine is opposite over hypotenuse, right? So opposite over hypotenuse. Okay, so think of that as S-O-H. Cosine is adjacent over hypotenuse. So let's think of that as cosine is adjacent over hypotenuse. Okay, and then tangent, think of tangent. Okay, so tangent is length of the leg opposite over the leg adjacent. So we'll think of tangent as tangent is opposite over adjacent. Okay, so we've got S-O-H, C-A-H, and T-O-A. Man, that looks familiar. S-O-H, C-A-H, and T-O-A. SOHCAHTOA. Oh my goodness, what a coincidence. We just learned about SOHCAHTOA. I guess this would be a good way to remember these 3 trigonometric ratios. So sine is opposite over hypotenuse, so the opposite side over the hypotenuse side. Cosine is adjacent over hypotenuse. tangent is opposite over hypotenuse. Okay, so we're going to go through a couple of examples where we're going to use these. You might still be confused, like, okay, what does this have to do with anything? Okay, we're going to show you how these three things are helpful. So first it says, what are sine of A, cosine of A, and tangent of A for the triangle shown? Now, you are going to want to have a tab open to Desmos, okay, so that you can use the scientific calculator on there. So first, we've got this right triangle right here. Sine of A is opposite over hypotenuse. So the sine of A, we're going to take, so this is A right here. Opposite is 15, hypotenuse is 17. So you're going to take 15 divided by 17. Okay, so 15, let me get my calculator. 15 divided by 17. Okay, so the sine of A is 0.88. So 0.88. That's the sine of A. Now the cosine of A is adjacent over hypotenuse. Okay, so we want the adjacent side. Remember, adjacent means right next to. Okay, the leg that's touching the angle. Not the hypotenuse that's touching the angle, it's the leg that's touching the angle. So adjacent over hypotenuse is 8 over the hypotenuse of 17. So 8 divided by 17. Let's go ahead and plug that into our calculator. 8 divided by 17, 0.47. So that's the cosine of A. And then last, we've got the tangent of A, which is opposite over adjacent. So opposite over adjacent. So 15 over 8. 15 divided by 8 is 1.87 or 1.88. We'll round it up like so. All right, so that's how we can find the sine, the cosine, and the tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, what I want you to do then, I want you to go ahead and find the sine of E, the cosine of E, and the tangent of E. Here's E right here. Go ahead and pause the video and find those links right now. All right, so hopefully you took the time to actually solve those in your notebook. So for the opposite over hypotenuse, we want, so the opposite is this side right here. That's 9 over the hypotenuse of 15. So 9 over 15. Okay, so we'll do 9 divided by 15. That's 0.6. Okay, now the cosine, CAH, adjacent over hypotenuse. Okay, adjacent, that's this side right here, adjacent over hypotenuse, so 12 over 15. So 12 divided by 15 gives you 0.8. And then tangent of E, that's TOA, opposite, oops, I messed that up. TOA, opposite over adjacent. So opposite over adjacent is 9 divided by 12. 9 divided by 12 gives us 0.75. Okay, so hopefully you're able to get each of those on your own. If you didn't, hopefully you recognize what your mistake is and once you saw me doing it. Okay, problem 2. Finding a trigonometric ratio. You can also use a calculator to find trigonometric ratios. In this chapter, use degree mode when finding trigonometric ratios. That allows you to enter angles in degrees. So basically, if you're using Desmos, okay, right here, this button right here lets you switch between degree and radian. You want to make sure that this degree, this little degree symbol is shown. So as it is right now, this is how we want it. Okay, so If we go back here, it says, what's the value of the cosine of 55 degrees to the nearest 10,000th? Well, if we go back to our calculator, you'll see there's 3 buttons right here. There's sine, cosine, and tangent. And what we want is we want the cosine of 55. So we're going to do cosine, enter this in, and then we're going to type in 55 right there. And that tells us right away what the cosine of 55 is. And it says we want it to the nearest 10,000th. Okay, so 10,000th. So this is tenths, hundredths, thousandths. This is 10,000ths right here. So we want this right here. So the number next to the 5 is a 7, so that's going to round the 5 up to 6, which means that our answer is 0.5736. That's the cosine of 55 degrees. Okay? So using your calculator now, I want you to go ahead and find A, B, C, and D. Find the value of the sine of 80 degrees, the tangent of 45 degrees, the cosine of 15 degrees, and the sine of 9 degrees. All right, so hopefully you took the time to actually work these out. The first one we're going to look at is the sine of 80 degrees. You should have 0.9848. Okay, next one is the tangent of 45 degrees. That's just 1. Okay, it's a whole number, 1. Next is the cosine of 15 degrees. Oops, let me go to the next. The cosine of 15 degrees, and that is 0.9659. And then the last one it is the sine of 9, which is 0.1564. Okay, now this reasoning here says describe the relationship between the sine of 45 degrees and the cosine of 45 degrees. Explain why this is true. Well, let's figure out what this is. So first, the sine of 45 degrees, let me go ahead and clear this. The sine of 45 degrees is 0.7071. The cosine of 45 degrees is also 0.7041. Now, why might this be true? Okay, well, let's think about this with the right triangle, right? Remember, our right triangle, this is a right angle. Okay, the sine of 45 degrees, remember, sine is, remember that's so, opposite over hypotenuse. So opposite over hypotenuse right here, right? The cosine of 45 degrees is adjacent over hypotenuse. Over hypotenuse. Now think about this. What's this angle right here going to be? If this is 90, this is 45, that means that this is also 45. Okay? That means that this side and this side have to be congruent. This is an isosceles right triangle. So opposite over hypotenuse is going to be the same as adjacent over hypotenuse. They're both going to be give you the same measure if if these angles are both the same, both 45 degrees. All right, problem 3, finding a missing side length. You can use trigonometry to find missing lengths in right triangle when you know the length of one side and the measure of an acute angle. Okay, so as long as you know one side and the measure of one of the acute angles, you can find the length of a missing side. Okay, so here it says to the nearest tenth, what is the value of x in the triangle at the right? So we want to know what this side is right here. We've got this angle, and then we've got the hypotenuse. So what we can use is we can use the sine of 48. Remember sine, so that's opposite over hypotenuse. So what we can do is we can set up the sine of 48 is equal to the opposite leg, that's x, over the hypotenuse, which is 14. Okay, so the sine of 48. First we want to find the sine of 48. Let me erase this. Okay, so let's use our calculator to find the sine of 48 degrees. So the sine of 48 is 0.7431. So 0.7431 is equal to x over 14. Okay, now how can we solve for x? Well, that's easy. We just multiply by 14 on both sides. So we'll times by 14 here, and we'll times by 14 here. So we're going to take our 0.7431, okay? And actually what we can do, what's probably better for us to do is just use this. So use this whole decimal, just so that we're more accurate, we'll use the whole decimal instead of 0.7431. And we'll take that times 14. And we get an answer of 10.4 because we went around to the nearest tenth. So x is equal to 10.4. Okay? Since we then have this side, we could also use the Pythagorean theorem then to find the third side as well. Okay? All right, what I want you to do is, it says to the nearest tenth, what's the value of x in this triangle? So you've got your angle, 35 degrees. Try and think which trigonometric ratio you can use to find the value of x. So go ahead and pause it and see if you can find this on your own first. All right, so hopefully you took the time to do it. So we need to think. So here's our angle. This side right here is an adjacent angle, and then we're trying to find the hypotenuse. Which trigonometric ratio do we use the adjacent side and the hypotenuse? That is cosine, right? Ka. Cosine is adjacent over hypotenuse. So what we're going to do is we're going to do the cosine of 35 degrees is equal to 1.575 divided by x, adjacent over hypotenuse. Okay? Well, so to get x by itself, first we will multiply by x on both sides. That gets rid of this. And then we're going to want to divide by the cosine of 35. So because we get x times the cosine of 35 equals 1.575. And then we want to divide by the cosine of 35 to cancel this out right here so that we get x by itself. So we'll divide by the cosine of 35. So using our calculators now, we're going to take 1.575 divided by the cosine of 35 degrees. And you can see we get 1.9. So x is equal to 1.9. Okay? So hopefully you're able to get that. If you didn't get that, hopefully you can at least see what your mistake was. Okay? And then problem 4, finding the measures of angles. So here it says, if you know the lengths of two sides of a right triangle, you can find a trigonometric ratio for each acute angle of the triangle. If you know a trigonometric ratio for an angle, you can use the inverse of the trigonometric ratio to find the measure of the angle. Now, you don't know what the inverse is. I'm going to show you what that is here. It's going to help you find the missing angles. It says use the sine of -1, so the inverse sine, the inverse cosine, and the inverse tangent feature on your calculator. So each of these, if we go to our calculator here, you'll see that there's sine, cosine, and tangent, but the inverse ones aren't shown. What you need to do is you need to click on this function tab right here, and here you'll see sine -1, cosine -1, tangent -1 right here. So the inverse sine, inverse cosine, inverse tangent. Okay, so coming back here, we want the measure of each angle in the triangle at the right. So step 1, since you know the length of the side adjacent to angle A, since you know the length of the side adjacent to angle A, that's 12, and the length of the hypotenuse, that's 24, use the cosine ratio. So first, the cosine of A, we know that the cosine of A is equal to 12 over 24. which is 0.5, right? So the cosine of A is 0.5. So to find the measure of angle A, we're going to take the inverse cosine of 0.5. So we're going to click the inverse cosine of, go back to main, 0.5, and that gets us our angle then of 60 degrees. So A is 60 degrees. Okay. Now we want to find B. B is easy to find, right? That's 90, because that's what that box means. That's 90 degrees. And then how would we find C? Well, we should know that the length or the measures of the triangle all add up to 180, right? So if this is 90, that's 60. That's 150 together, so then that leaves 30 degrees left over. Okay? All right, so what I want you to do is I want you to go ahead and find, it says in a right triangle, the side opposite of angle A is 8 millimeters long. The hypotenuse is 12 meters long. What's the measure of angle A? Go ahead and pause the video and see if you can find this on your own. All right, so hopefully you paused it. So the opposite is 8. The hypotenuse is 12. So we want opposite over hypotenuse, right? That's the sine. So the sine of A is equal to 8 over 12. So using our calculator, we're going to do 8 divided by 12. And we get 0.666666666. So what we're going to do is we are going to do the inverse of that then. So go to function, the inverse sine of, let's just do the inverse sine of 8 divided by 12, just to be more precise, and we get an angle of 41.8 degrees, approximately. Okay. All right, and then the last problem, you can use trigonometric ratios to measure some distances indirectly. To measure such distances, it is often convenient to use an angle of elevation or an angle of depression. So first, an angle of elevation. We've got a person standing right here, and then we've got a person up in this weather balloon up here, or this hot air balloon. Angle of elevation, so here is this guy's horizontal line of sight. If he looks up to the person in the balloon, it's an angle of elevation. His eyesight is being elevated up. An angle of depression is an angle from the horizontal down the line of sight, down to a line of sight, right? So here's if this person up here, his line of sight is horizontal. If he has to look down, it's an angle of depression, okay? When you solve real-world problems using trigonometric ratios, you often need to round your answers. The problem may tell you how to round, otherwise round your answers to the precision of the measurements used in the problem. So whatever they use in the problem, use those same measurements unless they tell you otherwise. So for instance, if the problem has measurements to the nearest 10 feet, you round your answer to the nearest 10 feet. All right, so suppose you are waiting in line for a ride. You see your friend at the top of the ride. So you are right here, this tiny little person, there's all these people in line for this ride. How far are you from the base of the ride? So this person, the ride right now is, your friend is this little guy are way up here at the top of the ride. They are 150 feet up in the air, and we are trying to figure out how far we are from the base of the ride right here. Okay. Well, so this angle right here is 20 degrees. We know the opposite side is 150, and we're trying to figure out the adjacent side. So we want opposite over adjacent. Which trigonometric ratio can we use to do opposite over adjacent? Well, that is tangent. So what we want is we want the tangent of 20 degrees, and that's equal to opposite over adjacent, which is 150 over x. Okay? Now if we solve for x, first we'll multiply by x on both sides, and then we're going to divide by the tangent of 20. That's going to cancel the tangent of 20 out here. Okay, so we've got 150 then over the tangent of 20. Okay, so we're going to plug this into our calculator then. So we've got 150 divided by the tangent of 20, and that gets us 412.1. Now, according to the previous slide, it says use the precision of the measurements used in the problem. So this is rounded to the nearest 10 feet, 150, right? So what we're going to do is we're going to round this to the nearest 10 feet as well. So we're going to round this down to 410 feet. So it says round to the nearest, to the measurement that it says right here in the problem. Okay, so after you move forward in the line, the angle of elevation to the top of the ride becomes 50 degrees. How far are you from the base of the ride now? So basically this gets changed to 50 degrees. So we're going to still use the tangent, except instead of tangent of 20, we're going to use the tangent of 50. So x then is going to be equal to 150 divided by the tangent of 20. So we'll go ahead and, sorry, not the tangent, it's not 20 anymore, it's tangent of 50 now. Okay, so 150 divided by the tangent of 50, which is 125.8, and we'll round that to 130 feet, to the nearest 10 feet. Okay, so as he's moving forward, he was originally 412, now he's 130 feet away. Okay, all right, so your assignment for tonight, or for today, is on Math Excel. It's a 10.6 homework. Again, this is the last lesson in the chapter. Next week we'll review, and then we'll take the test on Wednesday. Okay, if you guys have any questions over this lesson, make sure you email me with any questions. Email is joyoder@bps.k12.in.us. Okay, so make sure you're using that email. Email me if you have any questions. I am very happy to help. I will email you back within probably 5 to 10 minutes if you email me. Okay, have a good day. Hopefully you guys continue to stay safe and healthy. I'll see you guys later.